This lesson deals with supplemental problem 9.6. You can find this problem in the ECE202 ebook in the Chapter 9 Supplemental Problems on page 5. Let's use a Laplace transform to solve the following differential equation. 1 times the second derivative of x with respect to t plus 4 dx dt plus 3x is equal to e to the minus 2t. I wouldn't need two initial conditions, and suppose that that's equal to x of 0, which is equal to 1, and the first derivative of x evaluated at 0, and that's equal to 2. In our Chapter 9 notes on page 10, we had the nth derivative property. Let's use that to solve this differential equation. Okay, the first term is the second derivative of x with respect to t. Just replacing x by f in our Chapter 9 results. Decreasing powers of s, I have s squared, second derivative, then x of s, then minus s to the 1, x of 0, and then minus s to the 0 times the first derivative of x. So s is decreasing in powers, and likewise x is increasing in its derivatives. And I got 4 times only a first derivative, so again, same thing. I'm going to have s times x of s, and then minus s to the 0, and then x of 0. Now s to the 0 is equal to 1. And then lastly, I've got 3x, would just be 3x of s, and then the Laplace transform of the right-hand side of the equation is just 1 over s plus 2. Initial condition was equal to 1, so 1 times s, and then the derivative was equal to 2, and again, s to the 0 is equal to 1. First term then becomes s squared x of s minus s minus 2. This second term becomes 4 times x of s, and then minus 1 times the initial condition of 1. And then our other two terms. Pull out the x of s term, and I've got an s squared, 4 times s, and then I've got 3, a minus s, and I got a minus 2, and then a minus 4, so minus 6. And that's equal to our right-hand side of the equation, which is 1 over s plus 2. Put this on the other side of the equation as a plus s plus 6. Find a common denominator, it should be s plus 2, so multiplying s plus 6 times s plus 2, and then plus 1. So then our x of s would equal this expression divided by this term s squared plus 4s plus 3. Let's multiply this out. So we're going to get s squared, 6s plus 2s, and then 6 times 2 are 12, and then plus 1. These two combined give us 8s, and these two combined gives us 13. My numerator highest power is 2. My denominator would be 3. So I can use my partial fraction expansion. The roots of this are s plus 1 times s plus 3. In other words, if you multiply that out, you're going to get s squared plus 1s plus 3s, so that's 4s, and then plus 3 times 1. So then I got k1 over s plus 1, k2 over s plus 2, and k3 over s plus 3. So I'll multiply this expression here by s plus 1, and let s equal minus 1. Again, these terms cancel, and then I get a minus 1 squared minus 8s plus 13, minus 1 plus 2, minus 1 plus 3. This is equal to 6, this is equal to 1 times 2, and that gives me 3 overall. Same expression again, but now multiply it by s plus 2 and let s equal minus 2. Term cancellation. I get minus 2 squared, which is 4, minus 2 times 8, minus 16, plus 13, divided by minus 2 plus 1, minus 2 plus 3. This is going to be equal to 17 minus 16, or 1, minus 1, plus 1, an overall value then of minus 1. Take our same expression again and multiply it by s plus 3, and let s equal minus 3. Terms cancel. Minus 3 squared, which is 9, minus 3 times 8 is minus 24, plus 13, over minus 3 plus 1, and then minus 3 plus 2. Combining terms here, I've got 13 plus 9, which is 22, minus 24, so I get minus 2. This is equal to minus 2, and this is equal to minus 1. Minus 2's cancel, and I get 1 over minus 1, which is minus 1. So x of s then is equal to k1 over s plus 1, plus k2 over s plus 2, plus k3 over s plus 3, and that's equal to 3 minus 1 and minus 1. Taking the inverse Laplace transform of this using our table, this is just equal to 3 times e to the minus t, minus 1 times e to the minus 2t, and then minus 1 times e to the minus 3t, with the quantity times u of t, or just simply saying that t is greater than 0. And this is supplemental problem 9.6.